welcome back to 5.4 day 2. We are going to learn how to solve rational and radical functions, as well as solving radical inequalities and apply a solution to a real world context. So first of all, let's take a look here. We have a quadratic raised to a rational power. How do we solve those? Okay, so we have this x squared plus 5x plus 5 all to the 5 halves power equals 1. How do we eliminate that rational equation? Well, we're going to use our power properties. So we're going to raise this to the reciprocal, because we know if we multiply that, it's going to give us 1. And we're going to do that both sides, 2/5. Okay, so this ends up being x squared plus 5x plus 5. 5 halves of the 2/5 is just 1. And then 1 to the 2/5 power is also just 1. So what we have here now is a quadratic. So we're just going to solve this like a quadratic and get everything equal to 0. So x squared plus 5x plus 4 equals 0. And factors of 4 that add up to 5 are going to be x plus 4 times x plus 1 equals 0. So my solutions then are x equals -4 and x equals -1. So now we want to check both of these because we want to make sure we don't have any extraneous solutions. So we're going to plug these back up into our original equation. So we have this -4 squared plus 5 times -4 plus 5, all raised to the 5 halves equals 1. This becomes 16 minus 20 plus 5, all to the 5 halves. 16 minus 20 is -4, and -4 plus 5 is 1. And 1 to the 5 halves, of course, is just 1. So that checks out okay. Next, let's plug in -1. So we have -1 squared this time, plus 5 times -1 plus 5, and all of that is raised to the 5 halves equals 1. So this is +1 minus 5 plus 5 to the 5 halves equals 1. That's just 0. So 1 to the 5 halves is 1 equals 1, and that's good also. So both of these guys are solutions to our function. Okay, so we don't have any extraneous solutions there. Okay, so moving on. What about this guy? So we want to make sure on these guys that we have this isolated, this parentheses with the exponent. So I'm going to divide by 2 on both sides. So we have x minus 2 to the 2/3 equals 25. Okay, and we're going to do the same thing. We're going to raise the power up to the reciprocal on both sides. So this time it's going to be to the 3 halves. Okay, 3 halves. Now this one, the thing you want to be careful with is this right here. So anytime you raise it to an even root of any kind, that's like a square root. Remember, whenever you take the square root of both sides, you have to consider the positive and negative root. Remember, when you take, square root of both sides, have positive and negative. Same thing here. If it's an odd root there, not a problem, because it's just one solution. But if it's an even root, then we have to worry about that and make sure we take both solutions. Okay, so this becomes x minus 2 equals, so the square root of 25 is 5, cubed is 125. So we have plus or minus 125. Okay, so we have x minus 2 can equal positive 125, or x minus 2 can equal a negative 125. And now we have to go ahead and solve both of those. So x can equal 127, or if we solve for this guy, x can also equal negative 123. Now we want to make sure we don't have any extraneous solutions, so we're going to go ahead and check it. I'm going to check it over here in this equation because it's already simplified. So I'm going to go ahead and put in 127 minus 2 raised to the 2/3 equals 25. Okay, that's 125 to the 2/3 is 25. And the cube root of 125 is 5, and 5 squared is 25. So that works out good. That one's okay. Let's check the other one. This one's going to be negative 123 minus 2 to the 2/3 equals 25. And we have negative 125 to the 2/3 equals 25. Cube root of negative 125 this time is -5, but -5 squared is a positive 25. And so this one checks out also. So both of my solutions are good, x equals 127 and negative 123. Okay, so watch out for that, those even roots. Okay, next up here we have a try it. And so you might want to pause this video here, try to solve this on your own, and then come back and see how you do. So for this guy here, remember we want to isolate that parenthesis with my rational exponent. So I'm going to go ahead and add 14 here to both sides to get that rational exponent all by itself. So x squared minus 3x minus 6 to the 3/2 power equals 8. Okay. And so now I'm going to take this and raise it to its reciprocal. So the reciprocal of 3/2 is 2/3. Raise this to 2/3. Okay. So 3/2 times 2/3 now is a power of 1. So this just becomes x squared minus 3x minus 6 equals, now this is a cube root, so I don't need to worry about two solutions because cube roots only have single solutions, okay? The cube root of 8 is 2 and 2 squared is 4, okay? So now what I have here is just a quadratic, and so I just need to solve my quadratic like we always do, get everything equal to 0, x squared minus 3x minus 10 equals 0. Now factors of negative 10 that add up to negative 3 are going to be x minus 5 times x plus 2. Okay, so my solutions are going to be x equals 5 and negative 2. Right? So now let's go ahead and be sure to check those. And I like to check it in this equation right here because it's already simplified. So I'm going to check that in with my 5 first. So I'll put 5 squared minus 3 times 5 minus 6, and all of that is raised to the 3/2 equals 8. All right, so that's 25 minus 15 minus 6, all to the 3/2 equals 8. 25 minus 15 is 10, and 10 minus 6 is 4 to the 3/2. That equals 8. So then we have the square root of 4 is 2, and 2 cubed is 8. So that's 8 equals 8. So that one's good. Okay, let's try negative 2. So negative 2 squared minus 3 times negative 2 minus 6, and all of that is to the 3/2 equals 8. So this will be 4 plus 6, and then minus 6, all to the 3/2 equals 8. Those go away, right? So just 4 to the 3/2 equals 8. So the square root of 4 is 2, and 2 cubed again is 8. So 8 equals 8 is good. So both of those again are solutions, and we're good to go. Okay. So now next up we have this guy. We have powers on both sides. I'm going to use this guy, this rational one. That's the one I want to eliminate. So I'm going to use that one to raise the powers to both sides here. Okay, to 2/3. Raise this to 2/3. Okay, so I'm going to be left with my x plus 18 equals my x minus 2, and then 3 times 2/3 is going to leave me with x minus 2 squared. Okay, so now if I write this out and simplify it, x plus 18 equals, and this is the same thing as x minus 2 times x minus 2. Okay, I'd like to get you to the point where you don't have to write it out like that. Okay, so x plus 18, you can just go straight to x squared minus 4x plus 4 here. So now we just have a quadratic here, so we need to get everything equal to 0. Okay, so we have 0 equals x squared minus 5x, and then minus 14. So now we have factors of negative 14 add to negative 5 are going to give us x minus 7 and x plus 2. Okay, so my solutions are going to be x equals 7 and negative 2. So now we need to go ahead and check those guys again. And we want to check them, up here. We can't check them after we've raised the power, because that raising it to the power is what actually causes the extraneous solution. So we have to check it in this original equation right here. So we have we have 7 plus 18. That's going to be to the 3/2 power equals, and then 7 minus 2 cubed. Okay, so this is going to be 25 to the 3/2 equals 5 cubed. Okay, the square root of 25 is 5, and then cubed is 125, and then 5 cubed is 125. So that works out pretty good. Let's try -2. So -2 plus 18 to the 3/2 power equals -2 minus 2 cubed. Okay, this becomes 16 to the 3/2 equals -4 cubed. Well, the square root of 16 is 4, and 4 cubed is 64. And this is -4 cubed is -64. So this one does not work, okay? So the only solution we have here is x equals 7. That one's not going to work there, okay? So that's important of checking our extraneous solutions. Okay, now we're getting into radical functions, okay? Now this gets kind of interesting, so you might want to pay close attention. Okay, so what I want to do, I like to isolate the one with the binomial radical first, because this one's a little bit easier to deal with. So I have plus, I'm going to go ahead and add the square root of 2x to both sides. You can solve it the way it is, but it gets a little kind of gross to deal with, okay? So square root of x plus 9 equals, and a square root of 2x plus 3, okay? Well, what eliminates square roots is squaring, right? So we want to square both sides. So we're going to take this side and square it, and this entire side and square it, okay? This side just eliminates the radical, so that just becomes x plus 9. But the problem is this side, it's a binomial, so we have to go square root of 2x plus 3 times the square root of 2x plus 3. Okay, so you have to really pay attention to that. So let's figure out what that gives us here. So the square root of 2x times the square root of 2x is the square root of 2x squared. Okay, plus outside 3 times the square root of 2x. And another one, 3 times the square root of 2x. And then the 3 times 3 becomes plus 9. Okay, so this becomes x plus 9. This square and square root just eliminates the square root, right? So that just becomes 2x. These are like radicals, so that becomes 6 square root of 2x plus 9. So now we still have a radical in this equation. So we want to isolate that radical so we can get rid of it, okay, and solve. So I'm going to go ahead and we're going to subtract 2x on both sides. And we're also going to subtract this 9. Okay. So those cancel out, the 9s cancel out here, right? So we have negative x, here's my blue here, negative x equals, and then those cancel out, so that becomes 6 square root of 2x. Now right here, rather than divide by 6, I'm going to go ahead right here and square both sides, okay? And you could divide by 6, and I guess it would be okay, but I'm just going to go ahead and square right here, okay? So negative x squared becomes positive x squared, okay, equals, and this becomes 36, and then times, and then this square just eliminates the radical, so times 2x, okay? So this becomes x squared equals 72x. I'm going to come up here. Now if I subtract that from both sides, I'm going to get x squared minus 72x equals 0. Okay, so I'm basically subtracting 72x from both sides. Now I can factor out an x here, right? X times x minus 72. And that leaves me with x equals 0. Or x equals positive 72. Whoops, there we go. Okay, those are my two possible solutions. Now, I want to make sure I check this. Okay, so I have x equals 0 or x equals 72. So we know to check both of those guys here. So the square root of 0 plus 9 minus the square root of 2 times 0 equals 3. So this is the square root of 9 minus the square root of 0 equals 3. This is 3 minus 0 equals 3, so that's good to go. Let's check 72. The square root of 72 plus 9 minus the square root of 2 times 72 equals 3. This becomes the square root of 81 minus the square root of 2 times 72 is 144 equals 3. So this is 9 minus 12 equals 3. And that becomes negative 3 equals 3. That is not true, right? So my 72 is not a solution. So this is my only solution, is x equals 0. Okay, so that's kind of a long process, right? We want to isolate. I like to isolate the bigger radical, so I'm just squaring it singularly. This one becomes a binomial, okay, and you multiply those. Once you simplify it, isolate that other single radical, and you can either divide by the 6. I just kind of like to keep it on one side when I square it, okay? So just take it step by step by step very carefully. Okay, so why don't you guys go ahead and try this one, go through step by step, and then come back and see how you do. Okay, so once again, I'm going to go ahead and isolate this big radical here. And that's going to give me the square root of x plus 4 equals the square root of 3x minus 2. I'm going to take a few shortcuts on this one, okay? So I'm going to square both sides. You should be able to do this when you're squaring a binomial. You shouldn't have to write it out every time. So hopefully you can follow this pattern now. So it's basically this first term squared, which is going to eliminate my radical. So that just becomes 3x, okay? Then I'm going to take my first time and last term because we're multiplying binomials, right? So 3x times negative 2 becomes negative 2 square root of 3x. And we do it twice because it becomes my other first time and last. So another 2 square root of 3x. And then it's my last term squared. So negative 2 times negative 2 is plus 4. Okay. So hopefully you've started to memorize, recognize that pattern by now. And if you need to write it out, that's okay. Go ahead and write it out. So this becomes x plus 4 equals 3x. I can combine these two, so minus 4 square root of 3x plus 4. And now I'm going to go ahead and subtract 3x from both sides. Subtract 4 from both sides. And I'm going to get a negative 2x equals, that goes to 0, 0, and negative 4 times the square root of 3x. And now I have the square root of 3x term kind of all by itself, so I can go ahead and square both sides here. Okay, so this gives me a positive 4x squared. So be careful, make sure you square both of those, okay? Make sure you square both of these. So negative 4 squared is 16. Square root of 3x squared, that just eliminates the radical, so it's just times 3x. Okay, we'll come up here. 4x squared equals 48x. And I'm just going to go ahead and subtract 48x from both sides. So 4x squared minus 48x equals 0. Now I can factor out a 4x. Leaves me with x minus 12. So if I set 4x equal to 0, it's just going to give me x equals 0 and x equals 12. Those are my two solutions. X equals 0 and x equals 12. Okay, so x equals 0, x equals 12. So let's go ahead and check those guys. Square root of 0 plus 4 minus the square root of 3 times 0 equals negative 2. Square root of 4 minus the square root of 0 equals negative, equal, what happened there? Too many negatives. Turns into an equal sign. Negative 2. 2 minus 0 equals negative 2, and that does not work, right? So my 0 is not a solution. Let's check out 12. The square root of 12 plus 4 minus the square root of 3 times 12 equals negative 2. This is the square root of 16 minus the square root of 36 equals negative 2. 4 minus 6, negative 2 equals negative 2, and that one is good to go. So that is our solution, is x equals 12. Okay? All right. So those just require a little bit of patience. Now we're going to look at just some sort of an application to some of this stuff. So the body surface area of a human being is used to determine the doses of medication. The formula for finding that BSA is in this formula right here. H is the height in centimeters and M is the mass in kilograms. A doctor calculates a particular dose of medication for a patient whose BSA is less than 1.9. So if the patient is 160 centimeters tall, what must the mass of the person be for the dose to be appropriate. So we're going to plug in the height right here of 160, and then our BSA, we want to put 1.9. So I'm going to flip the page here. So this is what it wants to look like. Our BSA needs to be less than 1.9. Okay, so that's the BSA, the patient is less than 1.9. Okay, so what we want to do here to solve for what the mass needs to be is we want to go ahead and raise both sides to squared, right? Power of 2. That will eliminate, I don't know where this little mark came from, that will eliminate our radical, which will be nice. So we have just 160 times m over 3600. It's got to be less than, now I get my little trusty calculator here, and we're just going to go 1.9 squared. That gives me 3.61. Okay, then I can go ahead and multiply both sides by 3600. Okay, so I'll end up with my 160. M has got to be less than, and I'm going to take this again here and multiply by 3600. So 12,996. Double check that, it disappeared on me. 996, okay? And then we're going to go ahead and divide by 160. 81.225. So if I divide by 160 here, we end up with my mass has got to be less than 81.225, right? Yeah, 81.225. Okay, so that's a mass where the mass has to be. Okay, so here's a graph of this particular equation. You can kind of even see if we go over here where the 1.9 right here, it's got to be beneath, right here, beneath here, my 81. Okay. All right, so here is kind of a summary of this entire unit. You guys have an Excel in Google Classroom, and then I will see you guys soon. Thanks a bunch. Bye-bye.